Hello everyone. I recorded this video in case you cannot come to Thursday's labs due to the weather condition. This Thursday's slides are based on the content from Chapter 2.1 to Chapter 2.4, data modeling and some basic concepts of ER diagram, entity relationship diagram. Before I go through today's slide, there are two things I want to mention. First is I modify the syllabus a little bit. Here in week 4, I decided to move the content in that Thursday's lab sections to that Tuesday's lecture, so you are not required to come to the lab sections that Thursday. And then for week 6, now I'm not sure how much time I will need to use for the first two topics, forward engineering and workbench logging and SSH logging. If I have enough time left on that Tuesday, which is October 4th, I will also move the assignment 3 review to that Tuesday's lecture. So again, you will not need to come to that week 6 lab section. The reason is because this semester, the lab sections for section 2 and 3 are actually pretty late in the evening. So I want to combine the content of lab sections into the lecture section, so you will not spend much time to come to class every Thursday evening. And another thing is, since now I have a full list of student name, this is how the TA and myself grade your work. If your last name starts from A to S, then the TA is a person who will be responsible for grading all your submissions, including quizzes, assignments, and projects. If your last name starts from T to Z, then you should contact me if you have any problems about your grading. Please be sure you contact the right person, otherwise we may not know the details about your submissions. Okay, so data modeling and ER diagram basics. Database design focuses on how the database structure will be used to store and manage end-user data. Data modeling, which is the first step in database design, refers to the process of creating a specific data model for a determined problem domain. Here, a problem domain means a clearly defined area within the real-world environment with a well-defined scope and borders. Data models are simple representations of complex real-world data structure and their characteristics, relationships, constraints, and transformations with the purpose of supporting a specific problem domain. Two other related concepts. First is a model. Model is abstractions of a real-world object or event. Another one is database models, refers to the implementations of a data model in a specific database system. Data models can facilitate interactions among the designers, the applications programs, and the end user. In short, data models are a communication tool. You are unlikely to create a good database without first creating appropriate data models. Here is a list of the data model basic building blocks. First is the entities. It will be represented as tables in database. Entity refers to the unique and distinct objects in the real world used to collect and store data. For example, entity can be a person, a place, a thing, an event, or a concept. Attributes are characteristics of an entity. In database, attribute is represented as field in the table. Relationships describes an association among entities. There are 3 types of relationships in data models: one-to-one, one-to-many, and many-to-many. We will see detailed example in the following slide. Constraint is restrictions placed on the data and used to ensure the data integrity. For example, employee salary must have a certain data range of the value. For example, the value should be between 6,000 and 50,000. And another example is a student's GPA. The value of a student GPA must be between 0 to 4. You cannot have a minus number for GPA or GPA. Usually, you cannot have a GPA over 4.0. That's called a constraint. Primary key and foreign keys are another 2 very important concepts you must understand in database design. A primary key is an attribute or combination of attributes that uniquely identifies any given row in a table. That means identifying any given record in an entity. A foreign key, FK, is a primary key of one table that has been placed into another table to create a common attribute. So we can refer to this example. This is an example, I think, in chapter 2. So here we have 2 tables. The first table is a customer table. The second table is an agent table. As you can see, the primary key of the customer table is the customer code. Starts from 110 to 119. So the value of customer code is unique, and it can be used to identify any given row in this customer table. And similarly, the primary key in the agent table is this agent code 501, 502, 503. Each key can identify a unique record, a given row in this table. So those 2 are primary key. I think that's pretty easy to understand. And the agent code is also used as a foreign key in the customer table. So remember what's the definition of foreign key? A foreign key is a primary key of one table that has been placed into another table to create a common attribute. In this example, the agent code is the primary key of the agent table that has been placed into the customer table to create a common attribute. Tables here are related to each other through the sharing of that common attribute, that foreign key. The common link between the customer and agent table enables you to match the customer to his or her sales agent even though the customer data are stored in one table and the salesman's data are stored in another table. For example, you can easily determine the customer, for example, this one, Casey Smith. Her sales agent is Han because the agent code attached here is 502, and 502 can identify a unique record in the agent table. Although those two tables are independent of each other, you can easily associate data between tables via this common link. So you may ask why we not just attach all these columns or these informations to the customer table. That's because it could first create data redundancy, because that means you unnecessarily store the same set of data in different place, and more importantly, you will have other problem if you modify any information in the agent table, and those columns which attached to the customer table cannot be modified simultaneously. So that's actually the problem we have talked about in file systems. The relational models like this one can provide a minimum level of controlled redundancy to eliminate most of the redundancies commonly found in file systems. So relationship should have a relationship name. A relationship name is a name association between entities. For this one, customers received invoice, and invoice was sent to customers. And this one is a little bit complex. As I said, there are three types of relationships in relational data models: one-to-one, one-to-many, and many-to-many. That's actually called the connectivities of a relationship, which refers to its classifications. And here there is another concept called the cardinalities. The cardinalities of a relationship is the number of instances of entity B that can be associated with entity A. There is a minimum cardinalities and a maximum cardinalities for each relationship. Here, in this case, this symbol, which is a vertical line, refers to the minimum number of records of B that can be associated with one record of A. This is a minimum cardinalities. And this symbol, which is L, refers to the maximum number of records of B that can be associated with one record of A. That's the maximum cardinalities. So we can say one instance, one record of A is associated with at least one record of B and at most many records of B. So A is associated with one to many records of B. And this circle here actually represents 0. So let's see how many records of A can be associated with one record of B. So here, one record of B can be associated with at minimum 0 records of A and maximum many records of A. So B is associated with 0 to many records of B. That's the cardinalities. You actually can identify the connectivities via the maximum cardinalities of both sides. So here the maximum cardinality is many. Here the maximum cardinality is also many. So this is a many-to-many relationship. So we can take a look at the first two examples. This one, a record of A is associated with one-to-many records of B, and one record of B is associated with 0 to 1 records of A. So this is a one-to-many relationships. A real-world example I can think about is A represents order, for example, an Amazon order, and B represents items. So one order, if placed, can include one-to-many items. It must, of course, include at least one items and as many as items. And one specific item is associated with either 0 order, it hasn't been sold, or if it has been sold, at most one order. That means an item is associated with 0 to 1 order. And the second example, a record of A is associated with 0 to 1 records of B, and the record of B is associated with 1 and only 1 records of A. So as you can see, check the maximum cardinalities. This is a 1-to-1 relationship. The cardinalities is 1-to-1. The connectivities is 1-to-1. And the real world example are, so like A is a person, B is a library account. So a person can have 0 to 1 library accounts in a certain library. Either like you don't have account, or if you have one, you can only have one account. And one library account is associated with one and only one person. That's example, the second example. The last one, we have already talked about it. A is associated with one-to-many records of B, and B is associated with 0 to many records of A, and the connectivities is many-to-many. So examples like A represents a teaching assistant, and B represents a course. So a TA can work with one-to-many courses within a semester, and a course can have 0 to many teaching assistant according to the class size usually. So like in our school, if the class size is more than 48, that course will not have any TA, so it's a 0. And if you have like I don't know, probably like more than 200 students, you can have like 2 or 3 TA for a certain class. So the maximum cardinalities is many, like TA course. TA can work with one-to-many course, and the course can have 0 to many teaching assistant. Okay, namely convention. So entity name should be descriptive of the objects in the business environment and use terminologies that is familiar to the users. Please be sure you use the singular format. And attribute also need to be descriptive of the data represented by that attribute. Proper naming can facilitate communication between parties and promote self-documentations. For this class, like for all entity name, attribute name, relationship names, please use lowercase letters. Entity relationship diagram, ERD, is geographical representations of entities and the relationship in a database structure. ERD mainly describes two sets of things. First is the conceptual database as viewed by end users. Second is three main components of a database: entities, attributes, and relationships. So this is figure 2.3 shows different ER model notations. So first one is called the chain notation. This is actually the earliest notations, I think developed in 1970s. In these notations, the connectivities, if it's a one-to-one, it's one-to-many or many-to-many relationship. The connectivities are written, as you can see, next to each entity box. Relationships are represented by a diamond connected to the related entities through a relationship line. The relationship name is written inside of that diamond. The next is called cross-full notation. We will mainly use this version notations for this class. The connectivities are represented by, as I said, by symbols. Vertical line means 1, arrow means many. If you see a circle, that means 0. And the relationship name is written above the relationship line. The next one, the UML class diagram notations. This is a newer class diagram notations, which is part of the Unified Modeling Language, UML. The connectivities are represented by lines with symbols. So here are two vertical lines, means maximum, minimum, and maximum. Cardinalities are both 1, and here it's used like number 1 to 1, and this is like 1 to many. Also, the UM notations use name in both sides of the relationship. So you have two relationship names. Please pay attention to this figure because it shows examples for each relationship. First is 1-to-many relationship, and many-to-many, 1-to-1. Be sure you can think about an example for each relationship types. That will be a question in assignment 1. So now we have introduced the ERD building blocks. So you may have the questions how to identify those entities, attributes, and relationships. It should be created according to the business rules. Business rules are brief, precise, and ambiguous descriptions of policy, procedures, or principles. From a database point of view, the connection of data becomes meaningful only when it reflects properly defined business rules. Properly written business rules are used to define the entities, attributes, relationship, and constraints. So here is a list of the business rules examples. First, an agent can serve many customers, and each customer may be served by one agent. You can infer this is actually a one-to-many relationship. agent is associated with many customer, and a customer is associated with one agent. And similarly, the next one customer can generate many invoices. Each of the many invoices is generated by only one customer. So this is also a one-to-many relationship. One customer is associated with many invoice, and one invoice is associated with one and only one customer. And the next one, a training session cannot be scheduled for fewer than 10 employees or for more than 30 employees. This business will actually reflect constraint. So for that training section entities, you should have an attribute probably called capacities, and the data value for that capacity attribute should be between 10 and 30. Okay. So next is how to translate business rules into data model. Components very simple. Nouns translating to entities. Verbs translating into relationships among entities. For example, the business rule, a customer may generate many invoice contains two nouns, right? Customer and invoice, and one verb, generate, that's associated with those two nouns. From this business rule, you can infer, first, customer and invoice are objects of interest for the environment and should be represented by two entities. And then there is a generate relationship between customer and invoice. And question, which can help you to identify the degree of relationship types. So how many instances of B are related to one instance of A, and then how many instances of A are related to one instance of B. So this example, let's see how to identify the degree of relationship types between student has class. So how many class can one student enroll? Many class. How many students can enroll in one class? Answer is also many students. So the relationship between student and class is a many-to-many relationship. So this is an example from assignment 1. Assignment 1 will ask you to draw the ER diagram for these two business rules. First is a customer can make many payments, and each payment is made by only one customer. So this is a one-to-many relationship. A customer can make one-to-many payment, and the payment is made usually by one and only one customer. And the next one, an agent serves many customers, and each customer is served by only one agent. This is similarly also a one-to-many relationship. So this is one agent serves one-to-many customer, and one customer is associated with one and only one agent. So I will show you how to create the ERD in MySQL Workbench in next Thursday's lab sections. Okay, so that's for the chapter 2 part. So from here, I want to talk about how to create a FSU CCI MySQL Workbench login. And I assume you all have installed the MySQL Workbench successfully now. And you can take a look at the notes here. Notes, MySQL Workbench, and SSH login. And this is like a detailed guidance of how to create the CCI MySQL Workbench login. And this server, I'm not in charge of this server. So Dr. Jawad, who is now in charge of this server, has already created account for, I assume, each student in this class. And he also creates a video about how to this one, MySQL Workbench login dot mp4. Is for like how to create the MySQL login. And this one, SSH login, is to teach you how to create SSH login if you are using a Windows platform. So this one, login 2, is like optional video to teach you some basic like command line. Using SSH, you can take a look if you are interested in. So unfortunately, I don't think it can be played online. So you should like download it to watch. So from here, I will also show you how to create the my SQL Workbench login. So open your MySQL Workbench, and then you can click this. As you can see, that there is a like plus icon. Click it, and this is for setting a new collection. Please be sure you first type the connection name before you pick up the connection method. Otherwise, your MySQL Workbench might stop working. So please be sure you first type the connection name, and then choose the connection method as standard TCP/IP over SSH. And then for this SSH host name, it's MySQL jawad.cci.fsu.edu. And so here, this set username and password is for SSH login. So for the username here, enter your FSU ID. And for the SSH password, enter your Blackboard password. And then don't modify anything here. The MySQL host name, MySQL server port, no. And this set of username and password is used to connect to the MySQL on that SSH server. So those two are like separate things. So here, this username, you also use your FSID. And for the password here, you please type your FSUID again. So not Blackboard password this time. And then test connection. Yeah, so you should be able to see this window. Successfully made the MySQL connections. And then click OK, connect OK here, and the setting will be saved here. As you can see, I have this kind of the quick link of the CCI student connection now. So you may, I think some of you may have problem in creating this connection. First could be you signed up for this class late. So Dr. Jawad creates an account for each of you according to the student list of last Friday. So if you sign up for this class after last Friday, so you might not have an account on the server now. So then, of course, you cannot set up the connection successfully. So for this problem, this one is slide 16. I leave the Dr. Jawad's contact information and his personal web page in the notes part. So I have already discussed with him. So please just send him an email. Tell him that you cannot create that connections. So and he can help you to figure out what's the problem. And another problem could be the internet problem. Sometimes if you are using the FSU Secure, the connection cannot be successfully created. So try to change to FSU Guest Internet to see if it works. And that's how to set up my Workbench CCI connections. And as I said, so this video, MySQL Workbench login.mp4 is similar to what I just demonstrated. And now I would like to demonstrate how to create the SSH login if you are using a Mac. So this SSH login.mp4 is for those of you who are using a PC, Windows. So if you are using a Windows, please refer to this video. And if you are using a Mac, here, please first open the terminal and then type SSH, your FSU ID at mysql-jawad.cci.fsu.edu. That's the SSH host name. And it will ask for the password. Here, please use the password of please use your Blackboard password. So be sure, as you can see, when I'm typing my password, it will not show. That's okay. It's actually already be entered just for the security consideration. It will not show to you, so it's okay. And here, now you have actually logged into the SSH CCI server. And next part is how to log in to MySQL. Here are my SQL space -u stand for user name, and then your FSU ID space -p stands for password, and then enter. It will ask for password again, and for this one, please enter your FSID account. For me, it's just HF13C. As you can see, I have already logged into the MySQL. So this is how you use SH login on a Mac version. Okay, so this page is for the grading, and we will have quiz 1 due by the end of this week, and this is a key point for quiz 1. All content are available in week 1 slides and chapter 1. Please be sure you go through this concept before you start quiz 1. And that's all for week 2. Thank you.